She dug a little deeper. She went and grabbed 5 off of one production line, I think, and 5 off the other production line. And when we actually looked at the spread of the data, what we found was that 1 actually produced stuff tighter into the average, right? 1 more spread out. And we made that analogous to like a person doing archery. 4 shots. Average those distances out. You get the bullseye as opposed to a person who went 1, 2, 3, 4. Who's more precise? Archer. Top or bottom?
Bottom.
So obviously, if you're looking for precision, you want to go with the bottom. And mathematically, we said we have to find a way to actually be able to create a number, so that we could create a number for A and a number for B, and say, oh, A's precision is this number, B's precision is this number, therefore I pick A. And so we started investigating different ways of talking about spread of data, about the average particularly. And we talked about deviation, but we said deviation doesn't work because we did a proof. Mungu, that proved that the sum of all deviations ends up equaling 0 regardless, so that was no good. We talked about the absolute value of deviation. I said probably not so useful because if you want to take derivatives later on of an absolute value, you have to break it up into what kind of a function? Piecewise function. So we said that's out. So then we asked, well, what other mathematical operation can you do to basically, when you have deviations that are negative, take care of that. What operation was it? Squaring, right? So we took the deviations and we squared those, and then we averaged those by dividing by n, and that is called variance. But in that case, since you're squaring everything, if you're dealing with meters, you have meters squared. If you want the units to be the same, you take the square root of that, and that is called standard deviation. And then we had 2 formulas. We had one for sample. Remember? And we had one for population, and that's where the difference came, right? Because for sample, what did you have in the denominator?
N-1.
Whereas for population, you had capital N, right? And what was the reason for that? Do you guys remember? That was very important. Why the -1? Mungu.
Because in a sample, you're not guaranteed to pick out the ones that are really far from the middle, which means you want to give more weight to the ones that might be closer to the middle.
Exactly. I'll build on what he just said. Data points, because when you're calculating variance or standard deviation, you don't have to write this, you have this. Because you're doing the square of the deviation, did I talk about how when you're further away from the average, squaring that deviation means those data points have way more weight on variance or standard deviation? So the fact that you're missing out on those data points that are really, really far away means that you're really keeping this number artificially small. Remember, this number should reflect this number. In an ideal world, we just take every single data point, right? But Joanna doesn't have time to go to every single cylinder, right, at the manufacturer and measure the actual diameter of every one. She only had time to do 5, right? So she has to use this formula. So the idea is that by putting the -1 here, the result that she gets from this formula should look a lot like the result she would have got if she actually went and sampled every single one. Does that make sense? No? Doesn't make sense?
Yeah. That makes sense, but it just puts more weight on.
Yeah, what it does is given the awareness that she's not likely to grab all the weird ones, right, all the extreme values, that -1 drops the denominator, which inflates this value, making it closer to reality, whereby reality is everything. I'm getting there, are you? I see you. Now, why 1, not 2? Remember I was telling you Gallo was going to ask his buddy, who's a prof of statistics in Nicaragua? The guy passed away. It's not so funny. The guy was young, too. He was quite young, actually. Anyhow.
Mr. Gallo.
But I think I know why. I think it's pretty. I have a simple reason why. Why not? Why can't you pick 2? Okay, for you to have a set of data, what's the minimum number that makes it a set of data, that makes it plural? 2, right? So if n is 1, right, and let's say Joanna, the laziest she could have been was to grab 2 samples, right? Then that would be 2. 2 less 1 would give you 1, and you're taking a root of it, I guess, to get the standard deviation. If you go less than that, if she only grabs 1, you have 1 less 1, which gives you a 0 in your denominator, which is indeterminate, right? if they would have gone with like a 3 over here, that means this equation only applies when you grab a minimum of how many data points? 4. So I think that's a good reason why.
But then I said, why couldn't it be a number that's smaller than 1? It'll still work in.
Why couldn't one be a number smaller than 1?
Like a half, because like.
Oh, like a half?
Yeah. Remember we talked about this? Because like it would still make the denominator dividable, so why not choose 1?
Why not go with a small, like a half value or a quarter value?
Aren't your n's whole numbers though?
Your n's are whole numbers, but mathematically what she's saying is still reasonable.
Why wouldn't it be like a factor of n? That makes more intuitive sense.
That's what Gal and I were talking about. Why not make it a factor of n? We gotta get that guy out of this stuff.
There's no other stat
What about
box.
the internet?
That's why I asked you guys to look. Maybe you guys can go online?
You get desserts?
Yeah, you get desserts. The best I can do is the explanation I just told you as to why it's 1, not a factor of n, not a 1 over 2 or 1 over 4. I don't know. Maybe they did some empirical testing and maybe they found that when you went with half values, you didn't get this value coming close enough to that. But I feel like that wouldn't be the way to do it. I feel like they would.
Mathematicians, they don't do the
Yeah, they don't go ahead and do like 50 trials and be like, that's good. I don't think so. I think the 1 works. I think there's something else there. So, you guys let me know. Maybe there'll be a bonus mark in it for you guys collectively or something. I know you guys care about marks. Okay, so figure it out. Maybe there'll be a bonus mark. Bonus marks. Bonus mark in muffins. Blueberry muffin.
Oh, by the way, when is Moon's group getting those pastries or whatever you were saying that he was going to get?
First of all, it's not going to be that many pastries because if I really go to Jules, then I can only like buy like 3 or 4 because they're like really expensive. But yeah, I'll go this week, next week, and we'll come in with a knife and you guys will go to town on your dessert. The pastry from there is like unbelievable. Huh? The list isn't done yet? Finish the list. Alright, so
What's the list?
the list of who voted for Mungu.
Were you there?
Alright, so then I gave you, to stick with sigma notation, I gave you guys a question which was a proof. Yes? You don't even remember.
Yes.
I'll do the proof with you guys, and when I'm done with the proof, we can give you another one, you can play around, and that's all I'm going to say about proofs to sigma notation. Okay, Michelle? Well, let's go through it. It was 17A, if I'm not mistaken. What page?
150. Okay.
Pay attention, ask questions now, don't be shy, stop me every which step of the way because I'm not going to be spending too much time on this and many of you are going to find this tricky. It was proved that S equals what? Or am I even close?
Yeah.
S equals?
the root of n,
Yeah.
open bracket, sigma x squared,
Yeah.
minus sigma x,
Yeah.
and all of and sigma x squared. So brackets around the second sigma x, and squared. Over n.
I don't know. Alright. Okay, first things first. That's just the question for the book. First things first. What they really should be writing here is underneath here there should be an I. Oh, they can't see that. There should be a what? An I equals 1 to n. And here there should be an I equals 1 to n. But what they're basically doing to save ink and paper and time is to say, okay, since we're going to be writing this stuff over and over again, let's come to an agreement. And the agreement is going to be as follows. Whenever I mean to start at 1 and finish at a final value, I'm just going to not write it in. By the way, what should there be next to the x? Subscript I. Okay? That would have been the correct way to do it. But they're omitting that. So don't think that that means something else. The correct way to do it would be to write from I is equal to 1 to n each time with a subscript I next to the x. Do you guys see what I'm saying? But we're just going to understand that they're dropping it. So we're going to drop it. But it doesn't mean that it doesn't exist and that it doesn't mean the same thing. Make sense? Now, if they meant to start at like 2 and go to n minus 2, they'd have to write that. So the assumption is going to be this: when you don't write anything, you're starting at 1 and you're going up to n. Anything else you got to indicate, because how is a person supposed to look at this and know that they meant that the writer meant starting at 2 and going to n minus 2? Okay, so is that clear? Yeah. Okay, so this is a proof, and that means these things are not yet equal. You have to show that they're equal. Yes.
Wouldn't one of the xi's be an x bar?
What of the xi's be an x bar? Is that what it said in the question?
It doesn't have anything in the question. It just says show that s equals that and s.
No, anytime you see an x, they mean an xi.
But doesn't x have an x bar? S have an x bar?
Doesn't x have an x bar? X bar.
S.
Doesn't s have an x bar?
Like what they're.
Oh no, you're missing it. I'm going to show. They're saying prove that s is equal to this. Now, what you're saying is this. You're saying, well, we know that by definition, s is equal to. Go ahead.
Sigma.
Now, s, is that for a is that standard deviation? Is that for a sample or for a population? What's the symbol for population? Standard deviation. That sigma, right? Not that sigma, but that sigma. Okay, so now, what is it by definition?
So the sigma, you have the xi minus x bar.
Where by x bar is average.
Yeah.
You square those deviations, you average those deviations, and you
Square root it.
right. Now the only thing we'll do differently is
Isn't it n minus 1?
yes, thank you. It's n minus 1 because of everything we've just discussed. And as we move down, I'm going to start dropping this stuff, right? Just like they did. So this we know is equal to this, and they're asking us to prove that this, which is this, equals the right side. Right? What time is it?
Game time.
Is it done?
10:45, 9:45. Oh, no,
Some game time.
I thought game time meant we're done. Okay. From now on, for the rest of the proof, I'm going to start dropping those things. Okay, so how many of you guys liked trig identities? Oh God. Like 2 people. And how many of you did not like them? Okay. So, I guess my job is to kind of show you how I think about doing what I'm going to do. There are many ways, as you guys remember from proofs, there are many ways you can get there, right? So I'm looking at the left, and I'm looking at the right. And I'll tell you the first thing that, so what I generally do when I look at a proof is I try and look for similarities and differences. So what are the similarities on the left and on the right?
Square root.
Square root, good. Anything else? What are the similarities? No good.
N minus 1 and
N minus 1, N minus 1. This one doesn't have an N. Well, that one has an N, but there's a similarity there. What other similarities? Numerator, denominator, numerator, denominator. We'll start pointing out some differences that you think may be able to be turned into similarities. I'll give you a hint. How many sigmas do you see here?
1.
How many do you see there?
2.
So what property did I say that you can apply to sigma notation that would start making more than one of those? The distributive property, right? Like you know that a times x plus 1 is equal to ax plus a, right? So maybe we could apply the distributive property. There's one problem though. Take a look at this. This has 2 terms which is squared. And when you have 2 terms and you square them, right? How many terms is that going to give you? 3, right? And then when you distribute that sigma, how many sigmas are you going to end up getting?
3.
And this one only has 2. Okay. Now if you're a really good chess player, you can think further and be like, I can see how 2 of those 3 terms are going to end up combining to make 1, in which case you'll end up with 2 here and 2 here. I'm not that good a chess player. So you know what I say at this point? I say, I'm in school, and they set this thing up to work. So I have a feeling that if I expand this and I distribute that, it'll start to come together for me. It's not the real world, it's school. And that's good. It's a little bit easier. So you guys following the logic so far? So then the first thing I got to do is I got to expand this. So that's just like, if I asked you to expand that, that's the same thing as a squared minus 2ab plus b squared. Agreed?
Yes.
You agree with that?
Yeah.
Okay. So then I'm going to do that. Michelle, does that make any sense so far? It does? So I'm going to write the sigma. I'm going to drop that notation as we discussed. Square the first term, x squared. I'm not going to write the I, even though it's there. Minus 2 times the first times the second, x bar. Yes, it's xi, but I'm leaving it out. Square the last term, plus x bar squared. Does that make sense so far? You guys, now, does that make any sense so far? It doesn't make any sense.
I want to say yes.
Okay, so tell me why it doesn't make sense. Tell me what I'm doing. Tell me what I'm doing wrong. Tell me what doesn't make sense. Talk to me. What's the story? Does this make sense?
Yeah.
Okay, so this is A, and this is B. And I just copy the sigma and I paste it. I ignore it, and then I just expand by the square. What's in the brackets right there? No?
Okay, yeah, that makes sense.
Is that just, are you patronizing me?
No,
Like it really does make sense?
kind of.
There's no kind of in that.
Well, like, I get it. I get it now. I don't know if I'm going to get it tomorrow.
Oh, okay, I go, but that's practice. Or at the very least, I got to know that you follow what I'm doing here. Do you follow that? Do you follow that this minus this squared is this squared minus 2x x bar plus x bar squared?
Yes.
That's all I did. I did that right there. But I left the sigma alone, and I left the divided by n minus 1 alone, and the root sign. Does that make sense? Like in terms of following along? Yeah? Okay.
Where did the I go?
Remember what I said? I'm going to start cheating like they do, and I'm just going to stop writing it.
Okay.
Remember I said I'm going to stop.
X
Look,
is
look.
xi?
Sorry, yeah?
And-
Yeah.
okay.
Whenever you see x, it's xi.
Okay.
And I'm also not going to write these anymore,
Okay.
top and bottom. You see? Look, I dropped them. Okay, now we're going to distribute. Nice. So we have sigma x. We have minus sigma 2x x bar plus sigma x bar squared. Do you guys remember I said you could do that? I showed you the proof for the distributive property.
Yeah.
So like sigma x plus y, for example, is the same thing as sigma x plus sigma y, or sigma x minus y is the same thing as sigma x minus sigma y. I showed you that, right?
Is that the square?
Which one is squared?
The first term.
The first one is squared. You are right. You are right. Good. Okay. Now, did I prove to you that you can take a constant out of a sigma? Okay. Okay.
Yes.
The next thing I want to do is I want to take that 2 out. I want to put it over here. Did I show you the proof of that?
Yes.
Wait, which one was that?
Is it just because it's multiplication?
Aside. Okay. What is the sum of a xi I equals 1 to n, where a is a constant, okay? Just look for a second and then write. Just look. That means axi plus axi plus dot 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 plus axi. How many times? N times. That's the same thing as factoring out the a, and then you have x1, what the hell? x1 plus x2. So it's like x1 plus x2 plus dot 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 plus x, shame on me, n, which is the same thing as a times sum of I equals 1 to n of xi. Do you guys agree with that? Yeah. It's like you're going ax1 plus ax2 plus ax3 plus ax4. How many times do you do that? You do that n times. Well, that means you have n terms where each term has a common factor of a. So if you factor out the a, you're left with x1 plus x2 plus x3 plus x4 all the way up to xn. Well, what is x1 plus x2 plus x3 all the way up to xn? It's just the sum of, from I is equal to 1 to n of xi times a. So guess what? This, as compared to this, is just like taking that a and putting it out front. And the reason why I'm showing you that is because I want you to do that with the 2 and the x bar over here. And I'll explain. So let's continue over here. So let's go. What we'll do is, I'm just going to write left side, and I'm going to write right side, and I'm going to do this to mean that I just copied and pasted that. I haven't changed the right side. I just want to write all of it again. Now, we have equals. I'm going to leave that term alone. And the reason why I'm going to leave that term alone is twofold. Number one, I don't know what I can do with it. I don't know what else to do with it. I don't see how I can play with it or change it. And second of all, when I backcheck and look at the right, I see a sum of xi squared there. Now granted, it has an n attached to it, but again, this is school, and hopefully they built this thing to work. So I'm not going to worry about it too much. Do you guys sort of follow the logic?
Yeah.
So I'm going to be like, I'm putting that down and I'm moving on. Because I'm hoping that it's going to end up looking like that term in the end. Yeah, the end will come off. Next, minus. Now, very important. 2 is a constant, right? So based on this, like the a can come out, the 2 can come out. But what else is a constant over here? See, this x really has an xi next to it, doesn't it? It really is this. That xi changes from x1 to x2 to x3. But does x bar have a subscript? No, because x bar is the average of all of the data points. And for a fixed set of data points, does your average ever change?
No.
So guess what? 2 is not only a constant, but
So is x bar.
so is x bar. So I can write down minus Arash 2,
X bar.
and then I'm left with sum of I equals 1 to n of xi. That's the only thing that's left. Next, x bar is a constant, right? When you square a constant, do you still have a constant?
Yeah.
So this is a constant. Do you remember I taught you guys what this is, the sum of a constant is? It just means a plus a plus a plus a plus a n times, which is just an a. In this case, your a is just an x bar squared. So I have plus n x bar squared, where x bar squared is my constant. You guys agree with that? Does that make any sense?
Can you
Yeah.
like explain like where you put the constant, like where how that changed? The sign?
Starting on this one.
Yeah, like what I still I understand that's a constant. Like where did you?
Here's the 2 is a constant.
Yeah, and so is x bar.
So this is like this times this times this.
Right.
So I can take both of these constants
Yeah.
and bring them out front.
Okay.
So when I do that, there they are out front. And what's the only thing
So
left after the sigma? The x.
So like what's the you just changed the order? What's the difference?
Why did I take them out?
Well, like what's the difference? You just changed it. It's still multiplying all but each by itself.
Yeah, but it's gonna help you prove.
Sorry, say that again? Yeah, yes, you're right. Well, because this is a proof. And what I want to end up with is a scenario like this. And what I'm seeing that you don't necessarily see yet. Okay, that's squared and that's squared. But here, what's the difference between this and this? This means sum of x squared. This means sum of x times sum of x again. And I think I can create that scenario. Because x bar by definition is what? Sum of x over n. Right? X bar means average, which means sum all of the x's up and divide by n. And if I turn that into that, then I'm going to have 2 sum of x's over there. And those are going to square. Right? And that's going to end up giving me a sum of x squared. So that's why I'm doing it. Yes?
I just
Maybe, Jordan, do you at least agree with what I've done so far?
Yeah.
Yeah?
I just. Yeah.
You don't understand why?
No, I just didn't see like what the difference was between multiplying like those 4 and those 4. Just the order, like why you changed the order.
Why I brought these out.
Yeah, I know they're constant. I just didn't.
I'll show you right now why. I'll show you why right now.
So just one quick thing. Anything that doesn't have a subscript is a constant.
No, you can't because stupid nothing. You're right. You're smart because that x, right? You're thinking it doesn't have a subscript. It's a constant, but it's not because what did we agree? The book is dropping i's.
No, I mean, yeah, like forget that.
If you have anything with a bar over it, means average, which is a constant.
Okay.
For sure. And any number is a constant. Any letter that doesn't represent a variable is a constant. N is a constant. Because what does n refer to? N refers to the number of data points in the sample, which isn't going to change. Now, this is important. X bar. X bar is average, right? What is average? Add up all the data points and divide by the number of data points, which is, I can replace that with that. I'm leaving out the 1 to n. divided by that. So that becomes that, and I still have that. I'm going to do the exact same thing over here. Plus n times what is average? Average sum of x divided by n. The only thing is it'll be squared. Alright, you had a question a while ago.
It was just to do with in the sampling, like if you were to select one, for example, if that's off, wouldn't that really just skew the results?
Yes. So you're not guaranteed.
Yeah.
Absolutely clever. Very true. All you can do is deal with likelihood. The formula is based on likelihood. Yeah, there is a fluke. There could be a fluky case where she went in and grabbed 5 that were like all really far off. But
even just one, wouldn't just one throw the whole thing off?
It'll start to throw it off. But I mean, hopefully, if she grabs one from this end that's far off, she grab one from the other end so that they. But you're right. It could potentially happen that you end up getting a number that is not representative of reality because you were that fluky case where you really grabbed the extreme cases or one of the extreme cases. Yeah.
Sir, where did the add come from?
Which end? That end?
No, the bottom. The one that's divided by.
The last thing that you wrote.
No. He's asking about the.
Take a look at this. By definition, what is average? Average is average is for sample. We call it x bar, right? That's average, right? Yeah. Go ahead, Joanna. It's the sum of.
So sigma xi over n. Is that it?
I is equal to 1 to n of x I over n. This means add up all the data points and divide by the number of data points. So if this is this, I replace this with this. That's that n. You see? This is by definition. This is by definition. Average is equal to that, and by definition it means add them all up, divide by n. What does that mean? That means x1 plus x2 plus x3 plus dot 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 plus xn divided by n. So that's where the n came from. Who thinks they can see where this is going? Who sees that we're actually, now we just, from this move to this move, you now just went to the top of the hill and now you're looking down. Now you can actually, you should be able to sort of see down the hill. Because why? Because,
Get the top.
yeah, who wants to tell me why? Who wants to explain how they can, Sam, go.
Once you get the first one to be over n, then you can just put everything, like, transferred over to the bottom.
He's going to make a denominator here of n.
Yeah.
Everything will be divided by n. That n is going to end up
On the bottom.
on the bottom, right?
Yeah.
So that's going to make us make a denominator that looks similar. What about the fact that we have 3 terms here and we want 2 terms?
Or isn't that's, you can just, what's that word again?
Group that like
Add? Or add or subtract?
No.
That fancy word?
Is it? Yeah, it is. Wait.
Okay, this has an n in the numerator and this has an n squared in the denominator, right? So why don't we do this? I'll write it out. What's that fancy word? Add. Okay, this and this together could be written as this, no?
Yeah.
I don't have to write them twice.
Yeah.
Furthermore, this is plus n. You know when you have a over b squared, that's the same thing as a squared over b squared?
Yeah.
So I have a over b all squared, so that becomes sum of x squared over n squared. Goodbye, and that drops down 1, right?
Yeah.
Ah. Now, take a look at this term, Sam, and this term. They're actually the exact same term.
So minus.
This is minus 2 blah, and this is plus blah. Where blah is sum of x all squared over n. Right? So you can combine these two to give you sum of x squared minus, if you have minus 2, think of it as minus 2w plus w. You're left with minus w. But what is w? W is this, which is sum of x all squared over n. And now one last move. We're going to do what Sam said. And the beauty of it is to create a common denominator here, I divide this term by n, but what must I multiply it by as well?
N.
Yeah, you've got to multiply top and bottom by n, but that's good because guess what you want?
N.
So you end up with that. That's over n. That's over n, right? Divided by n minus 1, right? But that's really, like a over n minus b over n is the same thing as a minus b over n, right? You can just write the denominator once. So rather than write it twice, I'll just write it once. We're one step away. We're one step away. We're not going anywhere because we're going to finish it. Now, what you basically have here is square root of a over b over c. But that's the same thing as square root of a over b over c over 1, which is the same thing as square root of a over b times the reciprocal, 1 over c, which gives you a over b times c. So that is the same thing as just taking that n and dropping it down. And I have no room.
So where's the AB stuff?
Okay, fine, I'll write it down here.
I have it on camera.
He has it on camera.
Okay.
And then that is the same thing as. Gosh, we're almost done, we're almost done. Come on, we went through all this, I'm not doing it again. Who followed it?
Oh,
I just missed all of it.
That's not bad.
You're pretty sure.
I missed the AB part.
Okay, but he's got it on camera.
I got it on camera.
Okay.
Upload
Was it just like
It's like if you have x over y, x divided, if you have x over y divided by w, do you know automatically that you can turn that into x over yw on the bottom? You remember that? Okay. Here, I'll show you. Here, look. Right? Do you know that that is the same thing as that?
now I know. Is it?
The reason why is, think about it this way. This is the same thing as this, right?
Right.
Which is the same thing as, turn this into multiplication. What do you have to do with that?
Okay, okay.
Flip it. What's a times 1? A. You see?
Yeah. Sir, I just ask
And from then on, you can use the graphing calculator to do the work because it'll save you a hell of a lot of time on a test. And my objective on a test is not to have you sitting there number crunching by hand for 50 minutes and then answer one other question. Okay? So this will be the one time you do it by hand. Make sure you do understand how to do it by hand. And I do reserve the right to maybe make you do it by hand one more time, say on a quiz. And after that, we'll do the same problem with the graphing calculator, the virtual one on the board. And make sure you understand how to do both. And you're going to film it too, right? All right. So let's make something up. I don't know. Okay. And I'm going to limit it to 4 data points. Okay, well, let's say this. We're making something up. The Daytona 500, that's where they race cars, right?
Yeah.
Okay, how many cars are there in the Daytona 500? Ballpark?
500.
You may have to make
It's
like,
like 55 maybe?
okay, fine. 4 cars are randomly sampled from the 50 which participated in a car race. The front left tire of each weight is measured for wear by taking its diameter. So let's say this. Are you guys clear on this so far? I hope you're getting this down. Four cars are randomly sampled from the 50 which participated in a car race. The front left tire of each is measured for wear by taking its diameter. And let's list the diameters. And the diameters were measured as follows. I don't know, how big is a car? What is that? We'll go with centimeters. So this is about 30 centimeters. 50 centimeters, let's say. Is that about sound reasonable?
For a car?
For a car, a race car? Is that too big?
What, for the wheel?
Yeah, the diameter of a wheel.
What did you say?
Of a tire.
What did you say, how big?
Give me a ruler. Where is the ruler? Do we have a ruler in here? You say 50 or 60? Okay, that's what I was thinking. Okay, so let's say 60 centimeters. Why do I put a dot after the 0? Annette? You guys know that?
Sorry, I couldn't.
When you write a 60 like that, you're implying that the only value that is significant is the 6. The 0 is just a placeholder. Okay? When you put a dot there, you mean you're measuring to the nearest 1. That 0 is significant. 61 centimeters, 57 centimeters, and 60. Okay. Calculate the average tire diameter and standard deviation for the sample set. No, we'll say standard deviation and variance, even though they're basically the same thing, for the sample set. Okay? Make sure that you get all this down because I'm going to erase it in a couple minutes.
Could you read that over again? Calculate
Yeah.
the average.
Calculate the average tire diameter. Did I say it was a diameter? Yeah. Calculate the average tire diameter, comma, standard deviation, and variance for the sample set. Why? Your dad's car battery died. You guys are brilliant. I love it. Did you hurt your foot? Did you have to change?
No, why would I have car keys if it didn't die?
Did you have to change the gauze on your foot? The blood, was there blood coming out of your foot when the battery died?
No, the battery just died.
Oh, Natalie's not happy right now. I just want you to know this. If you want to get admitted to my class from now on late, you have to up the ante. So
One time.
you can't come in now anymore and say my car battery died or my foot exploded. You have to get more and more
I was
creative.
held hostage by a Mexican.
Yeah, it's got to be I was held hostage by a Mexican drug cartel.
AKA
It's gotta be something like that. But you can't use that one either.
Damn it!
Okay, can I erase?
What if someone said like they saw a nice falafel place and they had to buy some food? That's what they were like.
That's smart. I like that. I could see that. Like I was in line for some good food. Yeah,
They saw a great falafel place and they had to stop and buy food.
Did you like the jerk chicken? It was great.
That was good.
Can we
They're
check
really
the
good.
tire diameter?
But if I don't know, like
To sell you though?
Yeah, just can I erase or not yet?
Wait.
So hurry up. Yes, sir.
it's like jerk chicken breast. You know, I don't like the bones in my tire. Like,
I love it. I love it.
I don't like the tire.
Like there is breast in there too, but they just
Yeah.
they cut it up into. But you know why they do that?
Why?
Because all the flavor is on the bone.
Yeah.
Because of the fat and the gelatin, right? So
Yeah.
whenever you cook meat on the bone, it always tastes way better. Like a leg of lamb, right? Whatever.
Stop it, Ryan.
Okay, we don't have an eraser.
Stop it, Ryan.
We don't have an eraser.
You were just holding one.
I was. I could use your hair. I heard that.
What?
Okay, so if you know what to do, then do it. You don't need to wait for me. For God's sake, just do it.
Full tuition? 3300. I don't even know if I did that.
Lorraine. The only thing you got to do is figure out which equation to pick, because now it's standard deviation. You got a couple options. So which equation are you going to pick? Sample. Why are you picking sample? That's right. So the denominator is going to have no n minus 1. Talk to me. Talk to me.
I was saying lower.
When's Lorraine?
Yeah, but
But it's a 5-page application.
we have 120, 170, 170, 230, 241. Is that 241?
Yeah.
The average is 60.25.
Yeah, I just wanted to know the sum first. So am I going with mu or am I going with x bar? X bar, because x bar is per sample. We did not take the entire population. We only grabbed 4 out of the 50. And what is it, 16 a quarter?
Yes.
Okay, so then that means to calculate, you got to get these things. And then we'll just divide by the number and get rid of the whole damn thing. We need the sum of those. Yes? Yes, we do. Okay. What's a quarter squared? What's that? That's 16. It can't be. It's 0.16?
No.
Can I get 60 less? Can I get what 0.25 squared is?
0.0625.
It's a 16.
0.625?
0. Yeah.
16, that's what we're trying to say. Okay. This will be 61 less 16 a quarter squared. This will be 57 less 16 a quarter squared. This will be 63 less 16 a quarter squared. And can I get some numbers here?
Decimal 5625.
Next.
10.5625.
10 point.
5625.
Other people should be verifying this.
7.5625.
Okay, so if we add all of these up, can I get a number?
19.3125.
19 point.
3125.
Somebody else double check that, please.
I get 18.75.
What? Sorry.
Mungu.
Sorry.
You were doing so well. 18 point.
75.
Anybody else? I shouldn't have erased Mungu. Does anybody else get 18.75?
It makes sense.
I'm not doing that in my head. I refuse. I refuse to do that in my head. Come on, guys. Okay, so are we going to use S or are we going to use sigma for our standard deviation or variance? Okay, so let's just, if I want variance, might as well grab that first and then you can take the square root of that and you can get your standard deviation. So that is this. Correct? And that's going to be that, 18.75 over 3, which is?
6.25.
Makes sense. 3 times 6 is 18, and 3/4 are 75. And the units of this, by the way, guys, will be what?
Centimeters.
Not centimeters. Sorry, the way I drew it over here, it does look like that. There, centimeters squared. Right? And we can move up here. the standard deviation is going to be the square root of that, yeah? 2.5 units? Okay.
Swag.
So, therefore, the average tire diameter was 60¼ centimeters with a standard dev and with a variance of 2.5 centimeters and 6¼ square centimeters respectively. Questions on that? Does that make sense? Take the time now to ask or write down and ask if you have any questions, and then what we'll do is we'll do the exact same thing over here so that you learn how to use the virtual calculator to do it, which is, you're going to be using the graphing calculator to do it because you know, if I give you, like Gallo's next test, he is showing them how to use the calculators now. So like on his next test, he assumes everybody's getting a calculator. So he's going to be expecting that you're going to take like all of 1 minute to do a problem like this. Okay? So that's why you're going to have to know how to do this.
Which one's the standard deviation?
The one that's us.
Then why did he do?
Wait, is this in relation to the car, the previous thing that we just proved?
Which thing? Which thing?
Never mind.
Leora's cars?
Oh no,
Sorry,
no,
Joanna's
the
cars?
equation that came out on the board.
Are you in the mind?
Pardon me? I wasn't here yesterday, so I'm completely
No.
lost in the woods.
Okay, as we've been developing all these equations, we introduced a new notation called sigma because we don't want to sit there and write x1 plus x2 plus x3.
I got that.
Then after that, I said, okay, well now you know this new notation, and given the fact that you knew, and then we also ended up doing a proof. Remember, the sum of the deviations always equals 0.
Yeah.
So I said, okay, now you were in that world. I gave you guys, I assigned you a proof, a difficult proof from the book. It wasn't that difficult. From the book, and we did that proof. Now it turned out that in that proof, the left side of that proof was S, which is standard deviation for a sample. But that's just coincidence.
Okay, so they're not related.
This is, yeah. Wait a minute. I don't think we have success here. I don't know, guys. Failed to set for last emu version? What the hell does that mean? Wanwu, where are you?
If you give him a muffin, he'll help you.
If I give it a Are you kidding me? I have a question, guys.
What's your question?
This port right here, if we hook up my laptop to it.
Yeah, you just gotta go to that. You just gotta go see what.
Yeah?
This Gregory does it.
So just pull this guy out. That's the gray, right? So that should work.
Hi, Annette. Come on. Ow, ow.
All right.
Whoa.
And I should be able to touch the screen too?
No.
No?
Oh, you touched that screen?
Yeah.
Do you have smart software?
No, so the software has to be here too, right?
I don't know. We'll see. We'll see.
Whatever. If I use it as a projector, it would be better if I can.
I think you can touch it.
Anybody have a memory stick handy?
Oh, I think that.
Pause that. That thing's paused, right?
No.
Okay, I can't use the touch screen. Whatever, I'm running it off my laptop. Okay, so we're going to do the exact same thing, and the nice thing about doing the exact same problem is it will verify whether or not we did it right. Okay? And this is the way you want to do this on tests and quizzes. Rather, this is the way if you have a graphing calculator available to you, you want to use it. Okay, so whatever, we'll go through the usual routine. We're going to clear the memory, right? So second function plus 7, 1 for all RAM, 2 for reset, and it's done, right? Now, similarly to other situations whereby you have data that you want to enter, we're going to do that here. This is one variable statistics or two variable statistics? Why? What's the variable in this case? Tire diameter, right? How could you make the situation a two variable situation? Put up your hand. Give me something. Morph the situation. Yes, Lior.
Like tire diameter over the like width of the tire, so it could just go up.
Yeah. Give me something that's two variable by incorporating this as a variable and bring in another variable that could be related, like a cause and effect thing. Yeah, Mungu.
Over time, like how many races they've had with that tire.
Ah, that's cool. You could do that, right? Or tire diameter as a function of what position they placed in the race. I don't know, maybe if you position better, you're either, I don't know, maybe you wear less or maybe you wear more, I don't know. But this is still one variable statistics. Okay, so we have to enter the data. Do you guys remember where we access the spreadsheet portion of this thing? What button we press?
Yeah, it wasn't stat.
Stat.
Edit.
And then we pick one for edit, right? And now what? This is it, right? So what's our first data point?
60.
Next?
61.
Because I can't see anything, yeah?
57.
Yeah?
63.
Okay, so we have our data, yes? Very simple. Now what we want to do is we want to get back to the main screen. So that's the quit option in yellow over here, right? The second function, press the mode button to access quit. And now all you want to do is you want to get it to give you the information for one variable statistics. So I believe we pressed the stat button if I'm not mistaken. I think we scroll to calc. Yeah. And take a look at option number 1. You see option number 1 for one variable statistic? You pick it. Now you have to tell it where that data is. What list do we see? Okay. Which is yellow key and the number 1. You hit enter. Boom. Now, everything is done. Now listen. A couple things that are important.
Oh man, that's so cool.
That is so cool.
So much swag.
It's not that cool.
It
Hey.
tells you everything that we did like.
Yeah, but it's a calculator. Okay, anyhow.
I love technology.
I do too. The important thing here is to know, this is important. It's giving you average with the symbol X bar. Mathematically, is the operation for calculating average for a sample or a population any different? No, it's just add them all up, divide by the number. But this calculator doesn't know that I did a sample or I did the entire population, right? So it doesn't bother writing, first of all, it doesn't know whether to write X bar or mu, and it doesn't write both. Since the numbers come out the same, it just writes one. So just know that if you entered all 50 race cars in here, right? This number, 60 1/4, would represent mu. Agreed? Okay, so that's average. Sample or population. Sigma x, that's a little freaky. It's giving you the sum of the data, whatever. Okay, but here is what's important. Again, the calculator does not know if you entered in data that was the entire population set or the sample set. And what formula does that start to distinguish itself at? Standard deviation or variance. So notice what it does give you. It gives you standard deviation for a sample, and it also gives you the sigma, the standard deviation, as if it was an entire population. In our particular case, which is the appropriate solution, top or bottom? Top, because it was SX is a sample, right? Does it make sense that the number is bigger than the denominator?
Yeah.
Why?
Because n-1.
That would have an n-1 denominator. Now, in reality, if we would have actually typed in the entire set of 50 cars, my hope would be that this number would work out close to the 2.5, right? Because that 2.5 is designed, the n-1, which gives you the 2.5, is designed to get you close to the reality of the entire population, right? This denominator is not the entire population. This is just the calculator not knowing. It's like, I don't know if you typed in a sample of data or all the data. If you typed in a sample of the data, then you want to go with the n-1 formula, which is the top. If the data that you typed in was the entire population, then you grabbed all the outlying data, all the extreme data, which means that I don't need to use the n-1 factor to be reflective of the real standard deviation. So it's that. By the way, what were our numbers? Was our average 60 1/4? It was 60 1/4. Our variance was Our variance was 6.25. Our standard deviation was 2.5, which is correct. To get the variance, what are you simply going to do with the standard deviation? You're going to square it. There's other stuff in here that's of importance, which we'll discuss. But you can see there's an arrow here, which means that there's more data down there. And if you scroll down, you have the smallest data point, minimum, you have max data point, but you have other stuff, Q1, Q3, medians, med stands for median, gives you the max value. Q1, Q3, that has to do with quartile stuff, which is very simple, which we'll discuss this class. Okay, we can actually do that right now. Okay, so are there any questions on this? Any questions on this so far?
Wait, how do you get there again?
To do this?
Yep.
All right. It's all, he's filming it, but okay, let's clear it. You go to stat, you go to 1 for edit, you enter your data points in here in L1 or in L2 or L3, whatever you want. Okay, any one of these columns. You go back to the stat button. No, wait. First you have to, I apologize, you have to,
Quit.
you want to quit because you want to be able to type in a command on a clear screen. You'll press the stat button, excuse me, you'll scroll over to calc, you'll pick one variable, statistics, you have to tell it where you're listed. If you typed it in L2, you have to tell it L2. We typed it in L1. By the way, if you ever hit enter on a function like that, without typing in a list, it will give you a solution. It defaults to what list? L1. So in our particular case, we actually didn't have to type L1, because it defaults it, but just type it, just so you get used to it. You hit enter and that's it. Okay? All right, so that's that. You know how to do it by hand. That's a hell of a lot faster, yeah? So what this number 2.5 is a quantitative representation of that graph. Remember the graphs we did like for Leora's stuff? The two companies both had the same average of Joanna's. The two averages were, for that example, 5, I believe, and one had tighter clustering about the average, and one had greater dispersion of the data about the average. The greater the dispersion, the greater the standard deviation would be. And if you actually apply the same formula to the data points for companies A and B, you should get a higher standard deviation for the graph that we had with the data that was further away from the average. So this is a quantitative measure of dispersion about the average. And given that we use average as our measure of central tendency. But we know there are other measures of central tendency, like median, right? Or like mode. Okay, so let's go back to median and take that to another place which is related, which is quartiles. And then we can look at percentiles, and it's very simple. And then we can be, I think, finished with this section. Then I think we can get to chapter 3, which is 2 variable statistics. Okay, so I'll make something else up. I'll just teach this in the context of a simple.
Do we have a date for a quiz or something?
We should book one, yeah. When do you want to do it? Because Gallo's booked a test. I'm trying to remember for when. Wait a minute. He's booked a test, I think, for a week, Monday. Okay. Up to 3.2 or 3.3. I'll find out. I'll let you know. Somebody want to go to Gallo's class and ask him?
I'll go.
Okay, go quickly. And just ask him, verify that the test is next Monday, and ask and verify how far we're going into chapter 3. Well, we'll go get him after. If he dies, well, if he dies. If he dies, you can call his parents. Okay, calculate. Oh, no, we'll do this. How about this?
It's just like,
and modify.
No, like my last name is really short. It looks funky.
I feel like, Chris or
Yeah.
I really need this.
I don't feel like
You feel like a Chris. You feel like a Chris.
I'll pretend my name is like Christopher. I'm pretty sure it's a girl's name.
Go with it.
Where the hell I went to K. You know that's the you know how Richard is also by the K. Christopher is K.
Okay.
K.
What did he say?
Which is a Monday.
October 17th, so that's next Monday. But did you ask him also up to what section?
With a bed.
It's 3 point something.
Oh god.
Okay, so there are these things called box and whisker plots or modified box and whisker plots. Who's ever seen a two-variable sketch of data whereby instead of seeing the data points just like this, you see data points like this? Anybody ever seen that?
So cute.
So cute. Imagine that each and every one of these data points was a data point that was arrived at as an average, let's say, of a bunch of data. So let's say you want to know the validity or certainty associated with each of the data points in a two-variable plot. Data points with a bigger spread are going to look like this. These things, each one of these is called a box and whisker plot. And it has to do with breaking data up into quartiles. And I'll be specific as to what I mean. Let's just do one of these for this data. There's a version called the box and whisker plot, and there's a version called the modified box and whisker plot. It's going to be very straightforward. You're following a recipe. Okay, so what you want to do in a situation like this is, the first thing that you would like to do, and the calculator, by the way, will do all the work for you too. So we'll do it by hand once, as I said, and then afterwards we'll get the calculator to do it. Yes?
Can you read the values from top to bottom?
Yeah. 23 kilos, 18 kilos, 17, 25, 2, 26, 28, 18. Okay? For a box and whisker plot, you're dealing with the median concept, or middle number concept, except you're going to be doing it 3 times. The first thing that you want to do is you want to actually relist the data in order from smallest value to greatest value. Somebody want to do that for me? What's my middle? 2 is my small, right? 2, next?
17.
Yeah.
18. 18. I can't see.
Can somebody see?
23.
23?
Yeah.
25. 26.
That's it?
I don't.
Is that it?
Yeah.
Okay, double check. 2, 4, 6, 8 data points. 2, 4, 6, 8 data points. Okay. The first thing that you want to do is you want to find the median. In this particular case, we have an even. I'll just say, I'll call it n. No, I don't want to call it n because you're going to think, oh, is that sample? Is that? Whatever. We'll call it.
Call it B for Ben.
N equals 8, which is even. So in this particular case, if you want to find the median, you're going to have to
Average 8 and 23.
average the 2 middle numbers, right? Okay. So what's a quick... Oh, up to what section is the test?
All of chapter 3.
All of chapter 3.
Oh,
We have a lot of work to do. Hi.
Miss K said here to take a test a half hour early.
Okay, but does she know where's this test?
She said, you're Mr. DeSalle, right?
No. 2, hang on. I think it's 2...
The thing is, the that person you don't want to know.
Okay, so... So mathematically, let's say, if mathematically speaking, very, very quickly, how do you find your middle data points? You take the total, yeah?
We take the total number and you find like the middle. Like
Yeah, so how do you do that? 8, you can divide that by
2.
2, okay?
The middle number meaning the median?
2 middle numbers.
Yeah, they just average them.
Okay, but that only gives me 1 number.
Wait.
So if there were 262 data points, what are your 2 middle numbers? Yes, which numbers? Like which term numbers?
132.
131, 132. So that's the same thing as taking that, dividing it by 2, right? You have 4, and then your other data point is going to be term.
That's 5.
Right. 1, 2, 3, 4, and 5, right? Just keep that in mind, okay? If you're entering data, right, and let's say it's a huge quantity of data, you're not going to sit there counting, right? So you just want to know, you can cut the data in half. The value that you get in this particular case is the 4th term, right? But you also want the 5th. Okay, so if we average these two, we say that the median of the data is 18 plus 23 over 2. 30, 41 over 2 is 20.5. Is that right?
Yeah.
Okay. So we're going to end up designing well, we'll say that's 20 now. That's good. Now, the next thing that we have to do is we use this 20 and a half. How much time do we have? Oh, yeah, we have so much time. We use this 20 and a half to break up the data into 2 halves. An upper half and a lower half. Because now what we're going to do is, for the lower half of the data, we're going to again find the median. And for the upper half, we're going to find the median. And so if you've created 3 medians, you've broken up your data into how many sections?
And then just 4.
4 sections. You've broken up your data into quartiles. And that's what a box and whisker plot is based on, breaking up your data into 4 chunks. When you take the median of data, you're breaking your data up into 2 chunks. When you're doing percentiles, you're taking your data and breaking it up into 100 chunks. Okay, so now what we do is we look to here and to here versus to here.
But isn't that 2?
Hang on a second. Okay, so we're going from 20 and a half to 28, right?
Yeah.
And the only thing I have to remember, I'm trying to remember, do I use the 20 and a half as a value to find the middle number, or do I go above the 20 and a half and only look at the 26? That's something I have to refresh my memory on. Do you know what I'm saying?
Yeah.
That is to say, if I look to the right of that median, then my answer is 26.
Why
But if
would it
I
be
don't,
25?
I have to average 25 and 26.
I think it's the average of 25 and 26. Because you're trying to split it into 4 equal parts.
I think so.
You see, like the 20.5 is just like a line. It doesn't really mean it's a data point.
No, but if it doesn't meet a data point, then my answer is 26.
But I think it's 25.5.
So that means you are including it in your calculation. You're
If
saying
it's a data point, your
No,
answer
I'm
is
not including it
25.
because I'm just taking the median of 23, 25, 26, and 28, in which case it's 25.
Oh, sorry, I didn't see the 23. Yeah, I didn't see the 23. Yeah, so you're ignoring it. You're treating it as a line. I think you're right. Can you pause for a second? Let's just double check. Quickly double check. Yeah, so the textbook is saying that when you actually look to take your median of the top half or the bottom half, you only look at actual data. Okay, that's going to be above or below. So in this particular case, we're at 20 and a half. So we're going to look at the data above. One more complication though. Let's say the median, let's say there was an actual 20 and a half in the data. What do you say? What do you say?
What do you mean if there's a 20? If you mean
Let's say the
on-
median turned out to be an actual number that was in.
Okay.
Would you ignore that number for top half and bottom half?
Yeah.
Because that's a median.
Sure. Let's go with that. Do you understand what I'm saying? Like, let's say there was a 21 here in the middle, and let's say the median number works out to be, well, it would have been worked out to be 21. Let's say there were 4 21s. Then my question is, when you look to get your median of your upper data, do you take into account the 21s?
You don't take account
Right.
the median.
So we're leaving out the actual median value when we go ahead and we grab the median of the top half and the bottom half.
If you have 4 21s, it's going to be
One of them's going to be.
21 because it's going to be the midpoint between 21 and 21.
No, but don't you count the other 21s to the right of it?
Yeah, like are we going to count,
Yeah.
like let's say there were 5 21s.
Then you count the ones
Are we
that
going
right
to
above.
count two, are we going to count the other 21s? Are we
You
gonna,
count 2 21s in the bottom half.
Yeah.
oh no, now you're saying,
No.
you're changing your tune. Now you're saying, yeah, you want to take 2 of the 21s and put them at the bottom and 2 of the 21s and put them at the
Because you
top.
said you had 5 of them. So then the one in the very middle
Is the median.
is the median, and then you have 2 which are in the bottom side and 2 that are in the top side.
So you don't include whatever the median is,
Yeah.
but that doesn't. You're not talking about the median value. You're just talking about what the median
Yeah,
is.
that seems reasonable. And I guess that would make sense too, because let's say you had 12 21s. You want the weight of the extra 21s to pull you in closer, because that means the data is actually clustered close to the middle. Okay, yeah, that makes sense. Okay, so then to recap what they're saying. Let's say there were like a lot of 21s. Let's say there were...
Enough 21s?
Yeah, enough 21s. Let's say you had 5 21s. And let's say the median value is 21, right?
Yeah.
And what we're saying is, when calculating the median for the top half, we would look at these two 21s as well as the 23, the 25, the 26, and the 28. And when looking at the median of the bottom half, we would look at these two 21s as well as the 18, 18, 17, and 2. The central 21 would mark the central cutoff point, which doesn't go to either side. Which does make sense to me, yeah.
So are you counting the 23 right there?
In this case, yeah, obviously. In this case, it's simple, because in this case, our median is 20 and a half. So we take every data point to the right of the 20 and a half, and every data point below the 20 and a half. But what if you had 5 21s, your median is 21, and my question was, do I just ignore all 21s in the top half or the bottom half, or do we use them? And what they're saying is, the middle of those 5 21s will represent the median of the entire set of data, and then they're saying, take 2 of those 21s and allocate them to the top half, take 2 of the 21s and allocate them to the bottom half. And I think that's reasonable, because let's say you had 101 21s. Those extra 21s, it means that the majority of the data is fairly tight to the actual median, and you want that reflected. Anyhow. Okay, after that long story, in this particular case, if we look at the top half, we have how many data points?
You gotta include
Even or odd? Even or odd?
Even.
Even. So what are we going to have to do? We're going to have to average those two. So that's going to give us...
35.5.
And in this particular case, we have to average these two, I suppose, which is going to give us a 17 and a half.
Yeah.
Okay, so what they call this, the middle of all the data is called the median. This value is called the first quartile, or Q1. But you know what it is. It represents the median of the lower half of data. And this value is given the name quartile 3, which is the median of the top. That gives me 8 times 1.5. What's wrong with me? It's 12, correct? Double check, please. Okay, Jordan, I'm waiting. Is that cool so far?
Yeah.
We took the full box width, not the gap from here to here, the full box width. 25.5 less 17.5. That's 8. 8 times 1.5 gives me 12.5. 8 and 4 is, sorry, gives me 12. 8 and 4 is 12. Now we're going to use that 12 to compare below the edge, the left edge, and above the right edge. So let's take 12 off the left edge and see if there's anything below that. So what is the left edge? The left edge is Q1, right? Q1 less 12 is 17.5 less 12, yeah, which is 5.5, right? Now, are there any data points below 5.5?
Yeah.
There is one. It's 2. So what we're going to do is we're going to take that data point of 2 out. Now, what's the next data point above that which is not below 5.5? 17. So 17 becomes your new left whisker, and 2 is your outlier. Okay? Now, Jordan, you're going to use the exact same 5.5, which is 1.5 times this, and check that on the right side. So when we do that, we're going to go Q3 plus 5.5. What's Q? What do you mean plus 12? Oh yeah, plus 12. So Q3 is 25.5 plus 12, which is going to give us 37.5. Are there any data points that are further than 37.5? No. So then the right side doesn't change. Yeah.
What do you call it? What
Thank you, Tim.
What do you call it when the 17 is like the new what? Like at the end?
It becomes the new whisker on the left side. And this is called an outlier. So we end up with one outlier on the left and no outliers on the right in the modified box and whisker plot. Can you conceive a situation where your modified box and whisker plot and your box and whisker plot will look exactly the same?
If the data is close together?
Yeah, that's right. If you don't have any data points that are further than 1.5 times the width of the box. That's it. Now, before you go, don't go anywhere yet. Here's what I wanted to show you, and get this on the camera because this is important. Check it out. It does a box and whisker plot for you. Let's say we were talking about our data before. What do you need? You need the minimum value, the maximum value. So there's your min value. It gives you Q1. It gives you your median. It gives you Q3. It gives you your max value. And another thing, I don't remember how to do it now. We'll do it next class. It'll also do a modified for you. I have to figure out how, but it'll also do. Sorry? You press stat plot? Okay, hang on. Tell me. Stat. We'll deal with it next class. Class is over. Okay.